Okay, so for this week, week 3, we're going to discuss Boolean Algebra. So our learning outcomes for this week is to relate first the basic operations and laws of Boolean algebra to circuits composed of logic gates. So ibig sabihin po, when there are circuits that is given to us, we can convert that to logic gates, and yung mga natutunan natin in the previous weeks about basic operations of logic gates, no? So yung truth table na itinuro ko, that will be mostly be applicable here in Boolean algebra. Second is to prove the theorems using postulates. And third is reduce Boolean expressions using the principles of Boolean algebra. And lastly, produce the complement of a Boolean function. So by the end of this session, or by the end of this discussion, you will be successfully understanding this kind of topics. Okay, so we will be tackling the theory behind and the application of a Boolean algebra. So, by definition, Boolean algebra is a part of mathematics dealing with operations involving logical elements, variables, and operators, axioms, and postulate. So, this is named after George Boole, an English mathematician, logician, and philosopher. This forms part of the core concepts for simplifying logic circuits. So, Boolean algebra greatly helps people, especially engineers, in better understanding circuitry, especially if it is given an equation or logic circuit equation. Tapos ang gagawin natin is to further simplify that logic circuit, okay, or what could be the output of that logic circuit. Okay, so it could be any form, no? So especially if it is made of complex logic circuit or logic diagram, so mas maintindihan natin siya at mas magkakaroon tayo ng better understanding about logic circuits if we use Boolean algebra. So we have here basic theorems and postulates of Boolean algebra. So si postulate 1 or closure, so sa postulate 1A, ang sabi daw is the structure is closed with respect to the operator plus. And postulate 1B states that the structure is closed with respect to the operator dot. Okay? So, when we go to the postulate 2 or the identity postulate, sabi sa 2A is x plus 0 is equal to x. While 2B states that x dot 1 is equal to x. Okay? So, yung x dot 1, kung gusto nyo siyang x multiply to 1, okay, so no problem. Pero yun po ay x dot 1. Then, theorem 1 states that x plus x naman would be equal to x. And 1b is equal to x dot x is equal to x. While theorem 3 for involution states that x prime, okay, or the complement of x prime, sabihin, ipa-prime mo pa yun na prime na nating x, wherein magkakaroon tayo na x prime prime. Hindi siya double prime ha, hindi po magiging double prime ang mangyayari. We are going to find the complement of x prime. So pag hinanap mo yung complement or yung prime ng x prime, makukuha mo is yung x. Then theorem 4 or associative. So sa 4a, you have x plus quantity y plus z is equal to x plus y. Then ipa-plus natin sa z. Sa 4b naman, if we have x multiplied to yz, we will have xy then z. Theorem 5, De Morgan. So sa 5a, we have the prime or the complement of x plus y is equal to x prime, y prime. Then 5b is equal to the product of xy, complement of that or prime, we will have x prime plus y prime. Then postulate 5, we have complement. Complement natin is when we have 5a, x plus x prime, we can have 1. Then for 5b, we have x dot x prime, we have 0. For theorem 2, So we have x plus 1 is equal to 1. Then x dot 0 is 0. For postulate 3, commutative, so x plus y is equal to y plus x. Then x dot y is equal to y dot x. Postulate 4, distributive, x multiplied to the quantity of y plus z is equal to xy plus xz. Then 4b is equal to x plus yz. Then x plus y multiplied to x plus z. Wherein yung ating x is didistribute natin to y and z. Then theorem 6, absorption. So, A natin or 6A is equal to x plus xy is equal to x. Then x is equal, multiplied to the quantity x plus y equal to x. So, these theorems and postulates of Boolean algebra are the equations or the conditions that you need to follow in solving or simplifying complex equations or complex equalities of logic circuits. So kailangan para makapag-derive ka ng sagot is magre-refer ka dito sa theorems and postulates of Boolean algebra. So proving theorems. So in order for you to prove theorems, so postulates need no proof. They are used to prove the theorems. So an example of proof is found in the table. So theorem 1A is a dual of theorem 1b and vice versa. Okay, so the steps for proving both theorems are duals of each others as well. So let's try theorem 1a here wherein we're given x plus x is equal to x. No? So ang statement natin is to have x plus x. So that is equal to, when we use postulate 2b, so yun yung ginamit nating justification for having that answer. So x plus x dot 1. Then simplify natin, so we will use postulate 5a. So ang mangyayari is yung 1 natin mako-convert natin to x plus x multiplied to the quantity x plus x prime. Then sisimplify natin ngayon using postulate 4b. Then magkakaroon tayo ng x plus x x prime. Okay? So using postulate 5b, magkakaroon tayo ng simplification of xx prime into 0. So magkakaroon tayo ng x plus 0. Then ngayon, using the postulate 2a, magkakaroon tayo ng answer na x. Therefore, x plus x is equal to x. So pag naman ginamit nyo yung dual niya, no? So yung x dot x, ano daw yung magiging sagot? So sabi, x dot x is equal to 0. So justify natin yon. So x dot x using postulate 2a is magkakaroon tayo ng xx plus 0. Ngayon, using postulate 5b, yung ating 0 magiging xx plus xx prime. Then using postulate 4a, so we will use postulate 4a. So magkakaroon tayo ng x is equal to, x multiplied to x plus x prime. Okay, so nilabas natin yung x in that equation. So ngayon, since meron ka ng x plus x prime, pwede natin gamitin yung postulate 5a. Magkakaroon tayo ng x dot 1. Therefore, x dot 1 using postulate 2b, so magkakaroon tayo ng simplification of x. Therefore, x dot x is equal to x. Okay? So, yung mga postulates natin, yung gagamitin natin para magkaroon tayo ng justification kung bakit natin siya na-convert into that simple answer. Kailangan ma-simplify natin siya, no? Until such time na wala na siyang wala nang postulate or theorem na tayo magagamit to answer that. So that would be the simplest conversion or answer for that theorem. So operator precedence natin. So meron tayong different precedence. We have the parentheses or yung paggamit natin kanina ng parentheses, yung paggamit natin ng not, and, at, or. Wherein yung truth table natin ay diniscuss natin in the previous week so that we can better understand how to use these operators in an equation. So Boolean function. So Boolean functions, by definition, is describe an algebraic expression consisting of binary variables, logic operations, and the constants 0 and 1. The output of the function is either 1 or 0. Boolean functions can be represented in three ways. It could be truth table, pwedeng algebraic expression, pwede ding circuit diagram. So yung tatlong yan is they are used hand in hand. Kumbaga, um, it's not just truth table. Minsan pinapagawa yan lahat, pinapagawa yung circuit diagram, pinapagawa din yung truth table and algebraic expression. Para mas maintindihan nyo kung paano na-derive si algebraic expression, nagkakaroon tayo ng circuit diagram. Ngayon, para naman makuha mo or maintindihan mo yung truth table, so magre-refer ka kay circuit diagram. No? So, mas na-visualize nyo po kasi yon if you have a circuit diagram. So, a Boolean function described in three ways. So, ito po yun, no? So, we have here an algebraic expression of function f is equal to x prime y prime z plus x prime y z plus x y prime. So, ito po yung circuit diagram niya. Okay? Okay. So, ayan po. Pag kinonvert mo yung ating function or output f to circuit diagram, ganito yung magiging itsura niya, no? So, magkakaroon ka ng x prime y prime z plus x prime y z plus xy prime as your output using operators natin na NAND or at saka yung NOT, di ba? So, pag ginamit natin yon, magkakaroon tayo ng circuit diagram. So, mas maintindihan natin yon if we use a truth table. Okay, so yung truth table natin using 3 gates, 'di ba no? So or 3 input. So yung XYZ mo, then yung output of your function f or yung output f natin is nakalagay doon. So that you understand what are the dapat na sagot no sa Boolean function natin. So ayun, as told by the definition, the output function or the output answers could be only 1 and 0. So simplification of Boolean expression with the rules of Boolean algebra. It entails manipulation of Boolean expressions according to the theorems and postulates. Simpler circuits can mean lower manufacturing cost, less wastage of resources. Okay, so tama po itong pangalawa, no? So in the industry po kasi, as much as possible, kailangan if you are to propose something to them or you are to troubleshoot something or to fix something po, kailangan mas simpleng circuit po yung gagawin mo. Hindi po kasi yun advantageous to them if you are to if they are to pay for something na pwede naman palang i-simplify, no? Kasi nga sayang sa pera, no? Sayang sa pera, sayang din yung resources na gagamitin mo, no? So kailangan po bago po 'yun pondohan or bago po 'yun i-approve ng ating management is kailangan na prove nyo po na yun na yung pinaka simpler circuit ng pwedeng or possible na pwedeng mangyari. So the function f is equal to x prime y prime z plus x prime y z plus xy prime is simplified into f1 is equal to xy prime plus x prime z. Sabihin na simplify pa natin siya into this format wherein yung f sub 1 natin is the new answer wherein it has xy prime plus x prime z compared dun sa mas mahabang function natin kanina. So the consensus theorem. So some Boolean expressions are not so easily simplified. So example daw natin is yung xy plus x prime z plus yz. The term yz is the consensus term. And we're in x plus x prime to the consensus term to eliminate it. And algebraic manipulation results in the simplified expression xy plus x prime z. Okay? So, yun yung sinasabi natin when it comes to consensus theorem. So, hindi lahat ng Boolean expressions are madaling i-convert. So, kailangan hanapan mo lagi siya ng butas kung saan mo siya pwedeng, kung saan natin siya pwedeng i-eliminate or magkaroon ng mas simpler function. So, complement of a function. The function is complemented if the output changes from 0 to 1 or 1 to 0. So ito na yung paggamit natin ng prime, di ba? So denoted by a prime, e.g. the complement of f is f prime, no? So if the complement of x is x prime, no? Laging pong pag hinahanap natin yung complement ng isang function, we will use prime to denote that. So combine with De Morgan's theorem to produce functions of different combination of logic operation. So an example here is to express the Boolean function f, which is equal to xy plus x prime z with a NAND and NOT function or operation, and b with or and not operation. So paano po yun? So ang gagawin natin is express natin muna in letter A sa NAND and not operation. So the answer for that is equal to f is equal to xy plus x prime z equal to the complement or the prime of the product ng xy prime x prime z prime. Okay, so yung loob ng x prime z prime may complement pa sila, no? Si xy ipa-prime mo pa yon, si x prime z prime, no? Sorry, x prime z ipa-prime pa natin yon. Then yung answer nilang dalawa is hahanapin mo pa yung complement nila. So that entails yung NAND and NOT operation. Okay? Then sa B naman is yung or and not, no? So i-or natin siya and ina-not natin siya. So yung x natin, xy plus x prime z, so mangyayari, magiging sagot natin is x prime, yung sum ng x prime plus y prime, ipa-prime natin yon or i-complement natin siya. Then yung x plus z prime, ipa-prime pa natin siya ulit. So yun na yung magiging or and not operation for the Boolean function nung ating given, which is xy plus x prime c. Okay, so that is the complement of a function. So mas madali siyang intindihan kasi ang kailangan lang naman nating intindihan is kinuha lang natin yung complement of that function, no? Nilagyan lang natin siya ng prime para lang malaman or ma-denote natin na yun ay naka-complement ng totoo niyang function. Okay, so that is the end for week 3. So let's try discussing week 4. Okay, so for week 4, so we have here the Boolean functions and their forms. So our learning outcomes for this week is to express first the Boolean functions into canonical and standard forms. Second, to obtain the Boolean function from reading the truth tables. And third, to construct two-level implementation circuit diagrams of Boolean function. So the canonical forms. Each term has all the variables, so prime or unprime, present. So by definition, product or implicant is a Boolean term of one or more literals joined by the AND operation. Then sum natin defined as a Boolean term of one or more literals joined by the OR operation. Min term is a product term involving all inputs. Example natin is xy prime z. So this is a 3-variable min term. While yung max term natin is a sum term involving all inputs. So example natin is a plus b prime, a 2-variable max term. So sa min term natin, gagamit po tayo ng lowercase letters at sa max term natin is capital letters or uppercase letter. So please take note of the terminologies here. We have product, sum, min term, and max term. So min terms and max term natin, so ito yung gagamitin po nating designations for their input. So kung input natin, for example, is sa XYZ is 0, 0, 0, min term natin is X prime, Y prime, Z prime. So designation natin doon is M naught. No? So max term natin is X plus Y plus Z. Designation is uppercase M naught. So yun yung ating gagamitin, no? Hindi po tayo magsa-start sa M1. So M0 muna tayo. M0 na lowercase at M0 na uppercase for max term. Okay, so ito yung magiging definition or magiging co-equivalent na min term and max term depende po sa input na makukuha natin, no? So yun po yung magiging sagot. So sum of min terms, product of max terms. So when we say sum of min terms, Boolean function of min terms joined by OR operations. Example natin is yung function f is equal to xyz prime plus x prime y prime z plus xy prime z. Product of max terms, a Boolean function of max terms joined by AND operation. Kung kanina, sum of min terms is OR, so product naman is AND. Okay? So function f is equal to x plus y multiplied to x plus y prime multiplied to x prime plus y prime. So functions natin here can be expressed in canonical form by either using the two. First is manipulating the Boolean expression and second is pwede tayong gumamit ng truth table. Okay, so something to think about. So find out how to express a function in sum of min terms form to an equivalent sum of max terms form. So pwede nyong i-try, i-research, or pwede nyo try sagutan here how to express a function from min terms, sum of min terms into sum of max terms. So ibig sabihin, kung meron tayong sum of min terms equation, paano natin hahanapin yung co-equivalent niya na sum of max terms? So sum of min terms, product of max terms. So we have here an example. So express the Boolean function f is equal to a prime b plus b prime c in sum of min terms form by a by algebraic manipulation and b by using truth table. So we have here a max term function. So we're in yung uppercase yung gamit natin, 'di ba? So ang pinapahanap sa atin is to express that into min terms and gagamit tayo ng algebraic manipulation, then gagamit tayo ng truth table. So gagawa tayo ng function here, function f is equal to a prime b plus b prime c. Ngayon, using yung mga using yung mga postulates natin and yung mga natutunan po natin kanina how to convert um or how to derive the min terms and max terms depending upon the input and output. So magkakaroon tayo na a prime b multiplied to the quantity c plus c prime, okay, plus b prime c multiplied to a plus a prime. Then we will expand that, no? So papalawakin natin siya, magkakaroon tayo ng a prime bc plus a prime b c prime. So dinistribute lang natin si a prime b, no? Plus a b prime c plus a prime b prime c. So dinistribute lang po natin yung function a prime b and b prime c doon sa ating uh, quantity sa loob, no? So therefore magkakaroon tayo ng a prime b prime c plus a prime b c prime plus a prime b c plus a b prime c. So upon derivation, magkakaroon tayo ng sagot na m1 plus m2 plus m3 plus m5. So that would be your algebraic manipulation. So makukuha mo na yung sum of min terms form niya, no? So since wala namang binigay na value or binigay na, no, ang pinapahanap lang sa inyo is yung algebraic manipulation forms, no? Then makukuha natin is for any function a, b, c. So magkakaroon tayo na summation of 1, 2, 3, and 5. No? So summation of terms natin ng 1, 2, 3, and 5. So ano naman yung truth table of f equals a prime b plus b prime c. So magkakaroon tayo ng ABC as the input, then yung f natin yung output. So kung makikita nyo here, no, so lahat ng may output 1, doon tayo mag-derive, no. So napansin nyo, no, sa output natin sa 0, yung m naught natin, so wala, 'di ba? 0. Meron tayong output 1, so m1 natin yon, output 2, meron m2, output 3 na 1 ulit. So 1, 2, 3, meron tayong output. Yung 4, nakita nyo po, wala. So hindi natin kasali yon. Then meron tayong 1 ulit sa panglima, so M5. Yung 6 and 7, wala ding output. Therefore, yung sum of min terms natin is equivalent kung saan lang may naging output 1. So therefore, M1 plus M2 plus M3 plus M5. Okay? So kahit saan nyo po hanapin, no, A or B, so makukuha nyo or madederive nyo yung answer natin. So sum of min terms, product of max terms, express the Boolean function f equals a prime b plus b prime c in product of max terms form, a by using algebraic manipulation and b by using truth table. So let's try again an example here. So this time naman, ang gagawin natin is product of max terms naman. So yung kanina is sum of min terms. Ngayon naman, product of max terms. So let's try. So f equals a prime b plus b prime c. So we will have a prime b plus b prime multiplied to the quantity a prime b plus c. So after that, we can have the quantity a prime plus b prime multiplied to b plus b prime multiplied to a prime plus c, then b plus c. Then we'll derive that, makakakuha tayo ng sagot na a prime plus b prime, then a prime plus c, then b plus c. So yung b plus b prime natin is pwede po kasi natin yon na gawing 1 po, no? B plus b prime, no? Pwede na natin siyang gawing 1. So therefore, pwede nyo na i-cancel out si b plus b prime. Then after po nun is quantity a prime plus b prime plus c, c prime. Then a prime plus a prime plus c plus b, b prime, multiply natin sa quantity ng b plus c plus a prime. Then mas papalawakin pa natin siya. So magkakaroon tayo ng a prime plus b prime plus c, then a prime plus b prime plus c prime. Then a prime plus b plus c, then a prime plus b prime plus c, then a plus b plus c, then a prime plus b plus c. Then, after that po, we can simplify the equation. So, a prime plus b prime plus c prime, then a prime plus b prime plus c, then a prime plus b plus c, then a plus b plus c. Okay? So, you need to simplify yung longer equation natin. No? So, hindi pwede na yan pa lang yung sagot. Kailangan makakuha tayo ng inputs, no, for the equation. So dahil meron na tayong apat, so pwede na natin sabihin na answer natin would be m0 dot m4 dot m6 dot m7. So let's try to find, no. So ngayon naman sa product of max term natin, ang kailangan natin is lahat na may output 0. So ngayon, alin po yung may output 0? So output 0 natin is yung kabaliktaran po ng input ng ating min term. So ngayon, yung F0, yung una natin, magkakaroon tayo ng uppercase M0, then M4, M6, and M7. Kung alin kanina dun sa output natin ang may value na 1, yun naman yung hindi natin papansinin. No? So ngayon, for our answer here, sa product of max terms, we have M0 plus, dot M4, dot M6, dot M7. So standard forms. For standard forms, it provides Boolean functions with any number of variables composing the sum or product terms. So when we define sum of products, this is the product terms joined by the OR operation wherein yung x natin is i-add natin sa y prime z. Then product of sums, some terms natin is joined by AND operation wherein x natin is multiply nyo sa y plus z. Then the quantity x prime plus y prime. So yun yung difference is sum of products and product of sums. So again here we have something to think about. You probably noticed that we can convert a Boolean function in standard form to its equivalent canonical form. So how about the other way around? Okay, so paano naman po if canonical, i-convert nyo sa standard form. So you can use research if you are pwede nyo sagutin yun or that could be your assignment po. No? So paano po i-convert yung canonical form into standard form. So si standard form natin, provides Boolean functions with any number of variables composing the sum or product terms. So as defined, di ba? Sum of products natin are yung nagjo-joined by or operation. So example is y prime plus x plus yz. Then yung product of sums natin are joined by AND operation with x multiplied to y plus z. Then multiply natin by x prime plus y prime. This results in a two-level logic diagram implementation of and OR gates. Inverters are not considered but are assumed that complements are readily available. So this is an example of two-level implementation. So two-level implementation of a function in sum of products form wherein meron tayong input na A, then yung B prime natin, then C prime. Okay, so two-level kasi gagamit tayo ng two-level implementation para makuha niya yung function f to have a plus b prime c prime. Okay? So, two-level implementation of a function using naman ng product of sums form. So, you can have this function f is equal to b multiplied to the quantity a plus b prime, then a prime plus b plus c. Okay? So, yun na yung magiging output mo pag gusto mo makita yung two-level implementation using circuit diagram. So, Boolean function of n variables. No variables results in either of two constant function. So, kung walang variable, dalawa lang ang pwede maging constant function mo. Either 0 or 1. So, if isa lang ang variable natin, may apat na Boolean function na possible. We have 0, x, x prime, and 1. Then, pag dalawa naman yung variables, there are 16 Boolean functions that are possible. So, in general, for n number of variables, we can construct 2 raised to 2 raised to n Boolean function. So, whatever the number of your function or variables, yun yung ipapalit mo sa n. Then, ang mangyari, kung ano man yun, then, i-raise yun ni 2. Let's say, you have 2, di ba? I-raise mo. Then, 2 raised to 2 is 4. Then, 2 raised to 4 is 16. So, that would be your Boolean function. Okay. So, that is the end of your week 4.